Are you aware that there are just 4 quantities important in an experimental work, measurement, or calculation involving gases? They are volume, pressure, temperature, and number of moles or mass. We have seen in the previous lesson that the Boyle's law gives the relationship between pressure and volume, while Charles' law gives the relationship between volume and temperature of gases. So, is there a single equation that represents the relationship between pressure, volume, and number of moles and temperature of gases? Of course, yes. It is called the general gas equation, otherwise known as the ideal gas equation. When Charles and Boyle's law are combined, we have a general equation that helps us determine the relationship between these 3 conditions and calculate the volume of a gas when there is a simultaneous change in temperature and pressure. Both laws are combined into a single expression known as the general gas equation. So, the 3 parameters stated appears in the general gas equation. That is, P1V1 over T1 equals P2V2 over T2. However, because it has been proven experimentally that equal volume of all gases at the same temperature and pressure contain the same number of molecules, and that 1 mole of any gas at standard temperature and pressure occupies a volume of 22.4 dm3. Hence, the general gas equation states that for an ideal gas, PV over T is a constant. That is, PV equals nRT, where P represents pressure in mmHg, that is, millimeter mercury. V represents volume in centimeter cube, and T represents temperature in Kelvin. N represents the number of moles. This equation is essential and can be used in various ways to determine missing values in the reaction of gases. I hope you enjoyed the class. See you next class. Bye for now.